So in this video, we're going to sketch the derivative of a quartic polynomial or fourth degree polynomial. So here's our polynomial. We want to sketch the derivative. So we're given a function f of x. We want to sketch the derivative f prime of x. And just like in the previous videos, we want to focus on the slopes of the tangent lines. So when I look at this, I see there's no discontinuity, so that's nice. I then want to focus on places where we have derivatives of 0. So those are going to be places where the tangent line slopes are 0. And those are going to occur, in this case, at our local minimums and local maximums. So right here, if I draw the tangent line, I get a horizontal tangent line, so the slope is 0. Right here, I get a slope of 0 for my tangent line, and right here at this local minimum, if we draw the tangent line to the graph at that point, we get a slope of 0 for the tangent line. So the tangent line slope is, can't draw my tangent line. My tangent line slope right there is going to be 0. So each place where the slope of the tangent line is equal to 0, the derivative will be equal to 0. So from here we walk down to the x-axis, put the point right there, and we know the derivative has to be 0, so it's going to pass through that point. The derivative is 0 at this value of x, which looks like x equal to 0. We get a derivative value of 0, and over here, walk up to the x-axis, right above this spot, and the derivative will need to be equal to 0 there. So just like in the previous video, if I draw or imagine vertical lines through the x coordinates where the derivative will need to be 0, those are going to break my graph into key sections. Those will be sections where the sign of the derivative might change. So the x-axis is one of those vertical lines in this case, and one more. I get a 0 right here. So through this point, that'll break the graph into 1, 2, 3, 4 distinct regions. So just like we did in the previous video, look to the left of this 0. Look at the graph and ask yourself the question: Are the tangent line slopes positive or negative? In this case, when we draw them in when we draw tangent lines in, we see they have negative slopes. So to the left of this vertical line, the derivative will be negative. We step across this vertical line, we look at the tangent line slopes, we see that they will be positive. Just like we did in the previous video, find and draw in the inflection point. Now step across this vertical line. Think about the tangent lines. Ask yourself, are the slopes of the tangent lines when you step across positive or negative? Here the tangent line's going downhill. I see it will have a negative slope. Draw through the graph. Identify where you think the inflection point is on the graph, that place where the rotational direction of the tangent lines change. Draw that inflection point in on the graph. Step across the 0. Look on the other side and say, hey, if I draw in tangent lines on this side, will the slopes be positive or negative? Here they're going uphill, so I'm going to have positive tangent lines. And once you've drawn in all of the inflection points and identified the sign of the derivative by looking at the signs of the tangent line slopes, you're ready to draw in your graph. So step across this 0. The derivative has to be negative, so I'm going to start down low. I'm going to draw up to the place where the tangent line had a slope of 0. I see that I have to draw through that 0 because the slopes of the derivatives change to positive. Sorry, the derivative changes to positive because the slopes of the tangent lines change to positive. So you're drawing up through this point. You're going to continue to draw up and positive until you get right above the x-coordinate of that inflection point. So draw up. Once you're above that inflection point, reverse and head back to this other 0. That corresponded to the tangent line having a slope of 0 right here. So draw back down in a smooth curve, as smooth as you can. Ooh, not going well. Get down to that 0. When you step across this vertical line, the derivative becomes negative, so I have to draw through. And I'm going to go until I'm below the smooth line, until I'm below this inflection point. Now I have to curve back to my 0 right here. When and now I need to walk through the x-axis because the derivative changes to positive. And there's no other special places to look at, so I'm just going to draw the arrow and say the function goes on forever. So there is my graph of my derivative f prime of x.